Hey everybody, this is going to be basically a review over what we've been doing for the first unit. This is the week at a glance for this week, and you should be watching this on the asynchronous day. I'll have a link right here, view the review video here. This is the video that I'm creating right now, so I'll link that when we're done. Okay, so a couple of things I'd like to go over. First of all, let's talk about the reading that I assigned. So once again, this is in OpenStax. OpenStax is the online textbook. We're going to go ahead and go and find the one that's here. I'll go back here so everybody can see. If you go to openstax.org, click on subjects science and pick astronomy. Second edition is 2E. Jump on that. Table of contents. We're going to go ahead and view online. Works better that way. And here we go. We did the first chapter, Science in the Universe, a brief tour. Okay, when you click on that, it starts off with an introduction to what this course is all about. And I had questions to go along with this. That was a Google Doc assignment. I'm not going to go through all of those right now. I do just want to hit kind of the main ideas of the chapter itself. And for that, I have created a, right here, a slideshow for that, OpenStax Chapter 1. You're welcome to look through that. It's in last week, week at a glance. So I'll just click on slideshow so we can show it. It's a lot of text. I just want to hit the main ideas. The reading starts off, what is the definition of astronomy, right? The study of objects that lie beyond our planet, and the processes by which these objects interact with one another. And it says it's more than that. It's learning about how our understanding of the universe and our place in it has changed since people first started looking up and wondering what it all is. It did then move into the nature of science, what science is, and the idea that we're trying to understand the world around us. And it did mention that there was a time that the smartest people around knew, in quotation marks, that the Earth was the center of the universe. The Aristotelian view, Aristotle saw the Earth as the center, and then the different objects were in these celestial spheres around it. It makes sense, all right? If you're standing on the Earth and you see the moon rise and the moon set and the sun rise and the sun set and the stars move around the Earth, it appears that the Earth is stationary and everything's moving around it. We now know that's not true, but it was science that figured that out, that it wasn't true. And this is what the chapter talked about over the next 2,000 years through observations and inventing telescopes and other tools to measure. It was determined, we now know that the Earth is an oblate spheroid. That just means it's a sphere, but it's a little shorter and wider than an actual sphere. It's a little, at the equator, a little wider at that diameter. One of 8 planets and countless asteroids and comets that orbit the sun in elliptical orbits. We know our sun is one of over 200 billion stars in our galaxy, which is one of possibly 200 billion galaxies in the universe, a universe that is about 13.8 billion years old and 93 billion light years in diameter, and is expanding faster than the speed of light. Hopefully that perks some questions in your head. So we went from being the center of a small universe to part of an unimaginably huge universe. And if you remember the Cosmos episode, Standing Up in the Milky Way, and they talked about Giordano Bruno, right, who had this idea that the universe was infinite, and what happened to him when he was kind of going against the beliefs at the time. Hypotheses. It says, in astronomy, scientists make observations, and from those observations, hypothesize explanations, and then continue to make more and better observations, trying to disprove their hypothesis. Like good scientists does everything they can to try to prove themselves wrong, right? And so if they're unable to, hopefully then they're correct. And other scientists do that too. just since I began teaching. I know I'm old, but this is just crazy. The age of the universe went from 15 to 20 billion years old to 13.8. We've discovered the first planets outside of our solar system called exoplanets, over 5,000 of them. And also think of it this way, this is since your parents have been in school too, right? You're learning things that we didn't know at the time that they were your age. We went from an expanding universe to one that's actually accelerating. There's actually a time when we didn't know if there was an open universe or a closed universe. The idea of that is the universe just going to continue to expand forever? Or will gravity catch up to it, start slowing everything down, then pull it all back together in what was known as the Big Crunch? We now know that there is not enough gravity, that there is a repelling force in our universe called dark energy that's actually causing the universe to expand faster. It's accelerating. We discover that all the moons, stars, planets, everything we can observe, asteroids, everything you see, everything you can detect in any way possible is only 5% of the universe. The rest is something called dark matter and dark energy, and we don't know what that is. 5%. Everything you see in the pictures, that's still 95% of the universe. We don't know what it is. It doesn't give off any light. And there's much, much more. So next was scientific notation. You will need to be able to understand how to work with scientific notation. I'll be sure to put some of that on the test. It's a mathematical abbreviation for numbering very large for writing very large numbers, right? And the idea is you put things down to one integer and then decimals. Then you say times 10 to the whatever power. If it's a large number, you'll be times 10 to the positive power. Tells you how many decimal places to move that. If it's a negative number, if it's a very small number, less than 0, you would do your exponents would be negative numbers. So this first one, 42 trillion kilometers, would be written as 4.2 times 10 to the 13th power. Astronomical distances, we learned what a light year was. A light year is the distance that light travels in a year. It's approximately, well, it probably says 9.46 times 10 to the 12th kilometers. So almost 10, I'll say trillion kilometers, if I remember right. I'm just going to move this if I can. Not moving. There we go. Okay. So what's easier to use? If you want to measure distances in space, would you rather use this number or just a light year? Of course, we want to use light years. We want to use a scale that is something that's usable. And we learned through various methods that we can use astronomical units in the solar system, and we use light years outside of the solar system. And we could also use something called parsecs. I think we had mentioned that at one time. So that's kind of the introduction part of our readings. I'm going to escape on here if I can. Come on, there we go. Oh, I'm sorry, we're on this part. Looking at stars is like looking back in time. This is available. Maybe I'll show this to you in class. It's a good one about what that actually means from a channel called Talk Nerdy to Me. I'll try to get to the next slide here without playing the video right now. I want to play that right now. Might be it. That's very possibly the last slide. Okay. Going back to what we've been talking about, let's take a look at our unit so far. So a couple of things. Slew quest, how big? Remember to get that handed in. Even if you can't get a picture of the sun or whatever, go through the entire thing. You'll be tested on this, right? The things that it has you do. It did a lot of scaling in here. And so make sure you can do scale models. If the moon were only 1 pixel, that's something we just did. What's the main idea behind that? What you're supposed to learn from it. And then in the folder here are all the things that we did in Schoology. Let's start here. OpenStax Chapter 1, Science in the Universe. Reflections, Standing Up in the Milky Way. That was the Neil deGrasse Tyson video. Where Are We? Genius by Stephen Hawking. Make sure that you understand those. Go through that assignment. Review what was said and done in that one. Powers of 10. was an Ed puzzle. Our slew quest, how big, of course, and then if the moon were only 1 pixel. So that's what your test will be based on. I'm going to go ahead and sign off here. If I were in this class reviewing, I would certainly start by going back to the beginning of the class. Sorry, you don't have to laugh, Ashton, at that picture again. So kind of go through what we did. Review these as you go. You can certainly take a look at some of these. One thing I didn't mention there was here, pale blue dot and the most astounding fact. Review those. I'm going to ask you questions about those two things. Pale blue dot was Carl Sagan's speech about our planet Earth, and most astounding fact was Neil deGrasse Tyson talking about what the most astounding fact was that he thought about the universe. Okay. Going on to the, sorry, I went in the wrong direction. Here we go. The next week we watched Standing Up in the Milky Way. We talked about the slew quest, and then the cosmic calendar. Please understand what the cosmic calendar is. Okay, review that. That was part of Standing Up in the Milky Way, but then I showed you the original Cosmos. And I guess there's another one in the newer Cosmos called Possible Worlds. I just saw an excerpt from that where he does the cosmic calendar again. Getting a sense of scale, we looked at the Kurzgesagt video, the reading again, slew, the slideshow, where are we? Something to take a look at. That's what we did before watching The Genius by Stephen Hawking, Where Are We? Where we took a look at, if the Earth were the size of a basketball, how big would the moon be and how far away? You should know those ratios a little bit. And then the slideshow, I just went over that part of this video. And then if the moon were only a pixel, there's the funny thing there. And then lastly, that was about it. I guess we just kind of wrapped things up this week then. Tuesday, just kind of going over everything. I will show you that video, give you some time to get everything caught up. Wednesday is your asynchronous day. Watch this video and then read over the learning targets assignment. That was a Google Doc I had you fill in. Any assignments, video note sheets, slew quest, etc. And then we'll take a test on our first unit on Thursday. That's okay. All right, now I'll stop. Let me know if you have